All right, guys, so this pretty much is kind of like a review of all Unit 1. So we're pretty much almost coming to an end. So we should be ready for an exam probably next week. So probably Thursday of next week. So just a heads up, I'm letting you guys all know. Because now it's all about practice. Now it's all about practice, guys. So here we go. You guys ready? So look at letter A. When you see this question on your exam, can you solve letter A without blinking?
Yes.
Yes. Can you do direct substitution on it?
Yes.
There it is. So all you do is direct substitution, plug it in. I'm going to put an equal sign. 2 minus 4, that's a negative 2. In the bottom, 2 squared is 4 plus 2 plus 2, so it looks like 8. So let me know. I make mistakes all the time. So negative 2, 8 reduces to negative 1/4. And that's it. You are done with that. Look at letter B.
I have a question.
Yes.
So whenever we answer the stuff, how are we supposed to write it? Is it like just limit as x approaches to? Do you have to put f of x, or you just put the answer?
If you are already plugging in stuff, you don't have to write the word limit because you're already saying that x is approaching 2. So you could have written, if you have this, you can just go 2 minus 4 over 2 squared plus 2 plus 2. See, there's no x anywhere. You see, but if there's an x in your expression, you got to write the word limit because you haven't evaluated the limit yet. Does that make sense? Yeah. All right, here we go. Look at letter B. Can I do direct substitution on that one? No, because you get 0 over 0, so something in your head should be ringing like, hey, I need to do something about it because it definitely has the limit. In the numerator, that's a difference of squares. Notice that I'm going to write the word limit because I haven't evaluated it yet. X plus 3, x minus 3. Are we still cool? In the bottom, two numbers that multiply give you negative 6 and add up to a negative 1. What is that? Yep. X minus 3, x plus 2. What cancels out? The x minus 3s. Now can I do direct substitution? Yes. So what's 3 plus 3? What's 2? What's 3 plus 2? There it is. 6 over 5. How do we feel? Letter C. Is there anything I can do on letter C? No, does not exist. Matter of fact, if you do direct substitution and you get a number over 0, it automatically does not exist. It's probably a vertical asymptote. This one is. It's a vertical asymptote at x equals 2. And that's it. Cool or not cool? All right, look at letter D. Same issue, same thing. You get a number over 0. So does this one exist? What about letter E? It's approaching positive infinity. I'm looking at what? Starts with letter E. End behavior, right? Or you can also say the coefficient in front. So exponent, power 1 on both, end behavior. 3x over 2x, what's that? 3 over 2. What about letter F? What's growing faster, the linear line in the numerator or the quadratic in the denominator? So what's something divided by huge? 0. See, it's not that bad. Your test will look similar to that. Look at the graph. You'll have graphs as well. Can you give me the limits by looking at graphs? Limit as x approaches infinity. What does it look like? This is g of x. Yeah. Do you see it way over here? It goes like forever like that and forever like that. So it looks like what? Negative 3. It doesn't look very good, but it is. There it is. Letter B, limit as it approaches negative infinity. It looks like what? 0. What about C? Negative 3 from the left. No, not negative infinity. Infinity. Negative 3 from the right. Negative infinity. 0 from the left. 0. 0 from the right. Infinity. 4 from the left. Infinity. 4 from the right. Infinity. Can we do that? You'll get a few tougher ones. We're not trying to trick you. I just want to make sure you can do them. Sum of cubes, difference of cubes. Do we know those formulas? The AP exam will not give you formulas. So you gotta have to know most of them, guys. That's the sum of cubes. Here's the difference of cubes. I can't do direct substitution on letter A because you get 0 over 0. Something should be ringing in your head. Oh, 0 over 0. I have the limit for sure. Notice the numerator is the sum of... Uh-oh. Yeah, sum of cubes. 2 times 2 times 2 is 8. If you've done the UH quiz, hopefully they've given you that one enough that you're already becoming a professional. Limit as x approaches negative 2, x plus 2, close, open, x squared minus 2x plus 4. All over x plus 2. What's going to cancel out? The x plus 2's. Now I can do direct substitution. Let's see, 2 squared is 4, 2 times 2 is 4, so 4 minus 4 is 0, so this looks like it's 4. And that's it. How do we feel, guys? Do we feel okay? Letter B. Letter B, you just got to be clever. You just got to observe something. So here's what I notice. Do you notice that the square root of x times the square root of x is x? And do you observe that 2 times 2 is 4? So really you can say that the bottom, the denominator, is the difference of squares. Isn't that cool? You can actually say that anything's the difference of squares, but whether it's a perfect square or not, that's the issue. Because you can take any two numbers and say, oh, let's do the difference of squares. So look, guys, I can go limit as x approaches 4, square root of x minus 2 over, in the bottom I can write square root of x minus 2, square root of x plus 2. See? What's going to cancel out? Yeah, the square root of x minus 2's. By the way, I stole that one from UH. UH has that question on quiz limits, quiz limits 2, part 2. Plug in a 4, square root of 4 is 2, 2 plus 2 is 4, so 1/4. Let me clean this, guys. Man, this screen is just torching hot. I think. Oh, sure it. Okay. You guys ready? What about this one? I can't do direct substitution. So yeah, it's all about experience, guys. The more experience you have, the more you'll be able to do stuff. So what's making it tougher, the numerator or denominator? The numerator. So it's I'm going to multiply by the conjugate of the numerator. So I'm going to go square root of x plus 16 plus 4 over square root of x plus 16 plus 4. That's just a 1. It looks like the difference of squares. So I'm going to write limit as x approaches 0. Square root times square root, the square root goes away, x plus 16. And then negative 4 times positive 4 is a minus 16. In the denominator, I'm not going to distribute. X square root of x plus 16 plus 4. And there it is. So all the middle stuff goes away, so it's nice and clean. And I'll slow down. Are we okay so far? Ask me, guys, ask me, because I can't read minds. The 16s zero out. And now that I've canceled out the 16s, now can I cancel out those x's? Yes. Now you can do direct substitution. So now look, if I plug in a 0 in for x, 0 plus 16 is 16, square root of 16 is 4, 4 plus 4 is 8, 1/8. Yay or nay? Okay. All right, letter D. Relax, go slow. Limit as x approaches 0. So you know what? That one's kind of, well, it doesn't matter. Do you know how this graph looks? No. You're close. Well, no, not close. So think about it. X over x. X over x. What's 5 divided by 5?
1.
What's 10 divided by 10? What's 100 divided by 100? It's always 1 as long as x is positive. You just got to think a little bit about it, guys. You don't have to think much. What if x is negative? What if x is negative? Negative 1. Because the numerator will always be positive and the denominator will be negative. See? So this one does not exist. This one does not exist. But if they were to ask, this one right here, and I'm telling you for a reason, guys, limit as x approaches 0 from the right of this function, you would tell me what? Yeah, I heard it. 1. You would tell me 1. If I were to tell you limit as x approaches 0 from the left of this function, you would tell me what? Negative 1. I'm telling you for a reason, guys. Hint, hint. What's up? What do you mean? Absolute value can be negative, but the denominator can be. If I told you that x is negative 5, you'd have a positive 5 in the numerator and a negative 5 in the denominator, so you get negative 1. So it's either 1 or negative 1. Oh, is it for attendance? For attendance? Okay. Yes, yes. All right, guys. We're back. Do you guys want to go over letter E or no? Because it's pretty much the same as all the others. Yeah? Okay. All right, letter E. All right, guys, let's focus. Letter E, I can't do direct substitution because I get a 0 on this guy right here in the denominator of the denominator, if that makes sense. So I'll factor out that guy really fast. See, x minus 2, x plus 1. See? X minus 2's go away. Now I can do direct substitution. So here's what I have. 3 to the power 2 plus sine of 2 pi over 2 to the 4th. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 plus, and then I'm plugging a 2 in here. You get 2 plus 1 is 3, so plus 1/3. Now the rest is, can you simplify that? Don't worry, it's not even difficult, guys. It's just arithmetic. Look, go slow. 3 squared is 9. What is sine of 2 pi? 0. Over, and then, let's see, I need a common denominator in the numerator, or a common denominator in the denominator, that makes sense. 6 times 3, what's that? 48? 16, 32, 48. So 48 over 3 plus 1 over 3. I'm just showing the work. 9 over 49 over 3. Keep, change, flip. 27 over 49. See? What's the what? Ask, guys, ask. Yes.
Okay, so that math you did, what were you showing?
What math?
The math right there. Is that the answer, the 27 over 49?
Yeah.
Okay. Can you like write out the key change list? Yeah, because I thought key was like
There you go. 9 times 3 is 27.
you just put like 9, yeah.
What else? What else, guys?
Oh, I see.
16 times 3, Miss Cepeda. I need to get a common denominator. All right, guys. Hold on, guys. You see this that I'm circling in black? I cannot add those until I get a common denominator. I want a 3 below the 16, so I multiply the 16 by 3 over 3. 16 times 3 is 48. That's where the 48 got there. So 48 over 3 is 16 plus 1/3. So then 48 plus 1 is 49. And then I did keep, change, flip. What's up, Muniz? There's the fraction. This is this part. So you have 1 over x plus 1. So when I plugged in a 2, 2 to the 4th, 2 times 2, 4, 4 times 2, 8 times 2, 16, plus 1 over 2 plus 1 is 3, so plus 1/3. No, hit me. What else? No, not literally. All right. Did we answer everything about that one, guys? Okay, here we go. Limits are hard. Well, they can be. When this, okay, look, so what you're looking at right here is the hardest BC question that year. That year, this is from the BC International Exam, only 9% of BC students, which are supposed to be like the all-stars, only 9% of the BC students got this question correct. That was the lowest question correct from all the questions in BC. Not Lagrange error, not a series questions, not an integration by parts, not any of those series or BC topics. It was this one right here, an AB topic. Do you guys think you guys can get it right? All right, give it a shot. This one is tricky. This one is tricky. Only 9% got it right, guys, so it's okay if you want to know how did last year's group did, no one last year got it right. But maybe one of you will get it right this time. Yeah, it's a trick one. It's not tricky on purpose, but it is tricky. Oh, no, not this one. This one's the easy one. The next one. But it's okay. It's okay. You'll probably got this one right. All right. What answer did you get for this one? Let's see. Limit as x approaches 1 for g of x. You got to do that one first. What's this limit? 2. So now you go limit as x approaches 2 for f of x, and that is 3. Good job. Check mark. This is from the CD. This one here. Jesus Christ. Relax, guys. This one here is only 9% got it right. Try that one. It helps to draw a picture of what 1 minus x squared looks like. How many think the answer is 1? One of you, okay. How many think the answer is 2? 2 of you. 2, okay. How many think the answer is 3? No one. How many think the answer is 4? No one. How many think the answer is non-existent? Only 2 of you, only 3 of you voted.
Let us cook, Chuck.
Okay, how much time do you guys need? No, too long. You get 2 minutes a question usually.
Give us 2 more.
I'll take a minute.
I'll go get one. I don't.
Up a little bit. Too far. No, down. It's the last question.
You're funny, miss. Oh, did you get it? All right. Raise your hand really like this so I can see how many chose A. There was 2 of you earlier. Just okay. One of you guys. How many chose? 2 of you guys. Okay. So 2 of you guys chose A. How many chose B? 1, 2. 2 of you guys. How many chose C? 1 of you guys. How many chose D? Oh wait, all you all chose 3. C. 3 of you guys. How many chose D? 0. How many chose non-existent? 1, 2, 3, 4, 5, 6, 7. And then I guess 7, 8, 9, 10, 11, 12, 13, 14. Guys, there's more than 14 of you guys. Okay. Yeah, someone finally got it right. Can you explain how you 3 got C? If you want to. All right, guys. But if you plug in 1 into this, it's undefined. But you are so close from the left. Why from the left? You're right, but why? You're so right, miss. All right. Here we go. I'm going to explain it. You were so close. No, you probably got it right. You just probably need to put the words into it. Guys, look at 1 minus x squared. Here's the big hint. Does this function, look at your range. It only goes up to 1. There's nothing that's going higher than 1. Here or nay. If I approach 0 from the left, I'm approaching 1, but notice from below. If I approach 0 from the right, I'm approaching 1, but from below. From below is like approaching from the left-hand side. Why? Because as you get closer and closer, that's like 0.9, 0.99, 0.999, 0.9999999, 0.999999999. Do you guys see what's happening? So this, because it's bounded, it's like approaching 1 from the left. Now, if it would have gone like something like this, then it would have been does not exist, because you approach 1 from the left as you approach 0, you approach 1 from the right as you approach 0, so then it would have been like, oh, undefined. But because it's bounded, because you don't go higher than that, if you approach 0 from the left, if you approach 0 from the right, I'm both approaching 1, so 0.9, 0.99, 0.999. Because you're approaching from below, it's like approaching from the left on a horizontal line. Does that make sense? So write that down. Put, you're approaching from below, which is like approaching from the left on a horizontal line. You are approaching from below, so that's like approaching from the left on a horizontal line. I do not think they will give you guys this question for AB, but if you are interested in taking BC, well look, this was a legit BC question in that year. Okay, then look, what is the limit of f as x approaches 1 from the left? 3. What is the limit of f as x approaches 1 from the left? 3. Yeah, this is f. This is graph of f. What is the limit as x approaches 1 from the left for f? 3. Did you guys see that? Or no? Does that make sense? Yeah, that's about as hard as it gets, guys. All right, so here we go. I'm going to start, guys. It says if cosine x equals c, if cosine x and c equals pi over 6, determine whether the limit as h approaches 0 of c plus h minus f of z over h exists, and give the value of the limit does exist. All right, so let's see. What do I want? I need f of pi over 6. So I'm going to write f of pi over 6 equals cosine of pi over 6. And cosine of pi over 6. Do you guys remember what cosine of pi over 6 is? Square root of 3 over 2. Good. You guys must have had a really good pre-cal teacher. All right, next one. You guys are probably getting tired of my jokes. Sorry, guys. Maybe they're not funny. Next one, we have f of c plus pi over h. F of c plus h. So that means I want f of pi over 6 plus h, which is cosine of pi over 6 plus h. Leave it alone. So let's see, what am I going to do? I'm going to do this. So I want to know limit as h approaches 0 of f of pi over 6 plus h minus f of pi over 6 all over h. Well, bless you. F of pi over 6 plus h is limit as h approaches 0 cosine pi over 6 plus h minus square root of 3 over 2. All this is over h. Are we still okay? All right. Once you get to there, guys, you can't simplify anymore unless you do a property from your pre-cal days. Do you remember what cosine A plus B is? I don't know how in depth we went with this last year because it wasn't tested on AP. This is cosine A, cosine B, minus sine A, sine B. Does that look familiar? That doesn't look familiar? This is a property, composite argument properties. So here we go. I'm going to write limit as h approaches 0. And I need cosine A, cosine B. So the A is like the pi over 6, the B is like the h. So I'm going to write cosine pi over 6 cosine h minus sine pi over 6 sine h minus square root of 3 over 2. All this is over h. And I'll slow down. Where did the what? All I did was use this, guys. The A was the pi over 6. The H was the B. From there, all right, guys, focus, focus, focus. Let me see if I can fit it in here. Limit as h approaches 0. Cosine of pi over 6. You guys told me what square root of 3 over 2. Cosine h minus sine pi over 6 is a half. Sine h minus square root of 3 over 2. All this is over h. I'm going to move these two. Because they're not in the other side of the equal sign, they remain with the sign. Are we okay so far? Yeah, there's no equal signs anywhere. So I'm going to keep the signs. I'm just going to rewrite it like this. Limit as h approaches 0. And I'm going to write square root of 3 over 2 cosine h minus square root of 3 over 2. That's a 3 there. Just came out kind of dumb. Minus 1/2 sine h. All this is over h. Are we still okay? I'm going to factor. Okay, I'll slow down. I'm going to factor out a square root of 3 over 2 from these two. So here we go. Limit as h approaches 0, square root of 3 over 2 factored out. And notice you have that famous formula. All that is over h. I haven't done anything crazy, guys. Are we still okay? Okay, here we go. Limit as h approaches 0. Square. I'm going to break this up into two. I'm going to break this up into that and this one, like that. Square root of 3 over 2 cosine h minus 1 over h minus limit as h approaches 0, 1/2 sine h over all this over h. Properties of limits. I can bring this guy to the front. Same thing with that half. So I'm going to have square root of 3 over 2 limit as h approaches 0 of cosine h minus 1 over h minus 1/2 limit as h approaches 0 sine h over h. This is what you have to do on that last question that you have on UH trig limits 5. Because you don't know derivatives yet. So don't even try and look at derivatives. Don't cheat. Because then you're going to miss out on all this awesome stuff. All right. Last thing. We know, and I'm going to put the properties here. We know limit as x approaches 0 of cosine x minus 1 over x is 0. And we know limit as x approaches 0 of sine x over x is 1. That's what we know. Because we know that, we have, got to do this again. Yeah, I'll have a new laptop come Wednesday. Here we go. Square root of 3 over 2 times 0 minus 1/2 times 1. So my final answer is just negative 1/2. Let me make sure it's still recording. Yeah. And there it is. You're going to need another property when you take this quiz. Let me write the other properties, guys. You're going to need either this one or you're going to need this one. Don't worry, I'll come back. Sine A plus B. Sine A plus B is, let's see, sine A cosine B plus cosine A sine B. You're going to need those. I'll be honest. I probably will not put that one on the exam. And if I do, it will probably be a bonus question. Oh, the property? Yeah. Those are the only properties you'll need. I'll probably put it as a bonus. I'll probably put it as a bonus. So there, you already know one of the questions in advance for Thursday's test. It's this one as a bonus, and I'll just change the pi over 6 to some other random number. Yes. That's what we're gonna do. One more notes tomorrow. That way we can do a review Wednesday. All right. This is not tested on AP. This is, all right guys, focus. This is on UH Quiz 2. If you keep getting this question wrong, I guess you can, send me an email that's the only question you're getting wrong, and I'll change your grade to a 100. But I'll teach you how to do this question right now. This is called the delta epsilon definition of limit. This is delta, lowercase. This is epsilon. This guy is like error. I'm assuming this is what most, I would say, tier 1 universities are probably doing, like MIT and, courses like that. If you go to UT Austin, I don't think they do the delta epsilon, or maybe they do. I don't know. I think the last time my kids that were at UT, they said that they weren't covering this. So it just depends on the professor, whether they want to do it or not. All right, so again, this just means like error. So all it means is how close do you got to get to 2 for your error to be 0.01 from 2/3. For you to be 0.01 away from 2/3. That's all it means. So here we go. So since it's like error, I'm going to go x over 3 minus 2/3 and the absolute value of that. And I want that absolute value to be less than 0.01. I want to be less than 0.01 away from 2/3. Does that make sense, guys? All right. So because my denominators are the same, I can just write absolute value of x minus 2 over 3 is less than 0.01. I'm going to multiply both sides by 3 times 3 times 3. So you have absolute value of x minus 2 less than equal to 0.03. Here's where you're going to stop. But I'm going to continue in case you have a professor that wants you to continue. If you wanted to find those x values that you'll have an error of 0.01 from 2/3, you would continue and you go plus 2 plus 2. And you would say that your x values have to be between 2.03 and 1.97. So as long as you're between there, you will have an error of 0.01 or less from 2/3. Does that make sense, guys? You're going to stop here, though. Your answer is this one, 0.03. So you look for an answer of 0.03, and that is this one right here. 0.03 is the same thing as 3 out of 100. And that's it. You're done. So you're going to stop at that 1 to the third step there. Does that make sense, guys? All right. And here we go. Now the rest is going to be simple for you guys. I don't think you're going to have any issues. Question number 1. What is the value as the limit as x approaches 1 from the, what does that little minus sign mean? From the left. So you're going to use the top equation because that has values to the left of x equals 1. Does that make sense? So you're just going to plug in direct substitution. What's 2 minus 1? And that's it. That's exactly how you do it, guys. Was that simple? Yes, you can do it. Look at the next one. What is the value of the limit as x approaches 1 from what direction? The right. If you're approaching from the right, you want values larger than 1. So that's where you're going to use the 1 in the bottom. So you just plug in a 1, direct substitution. What's 1 plus 1/2? 3 over 2. Done. Thank you. All right, look at number 3. What is the value of the limit as x approaches 1? Tell me why it doesn't exist, Boston. You were right. Perfect. She said it beautifully. I don't know if YouTube, if you can't hear, she said because the limits from the left and the right are not the same. Beautiful. All right. This one does not say the word limit. It just says f of 1. What is f of 1? You just look where you're defined. You're defined in the top equation where x is 1. So what's 2 minus 1? 1. That's it. See? Oh, not that one. This one. Easy or not easy, guys? All right, look how short today is. So make sure you take advantage of today. So now, don't worry if you didn't do DM4B or you didn't get a chance to finish it. I know it says late. It's not going to be counted as late. Or at least, did I change the due date to Sunday? And for those of you, okay, relax. It's not late. Today is the due date for that. So try the DM4B limits galore. That one's due today. Now you know how to do every single question for quiz 2, limits 2. I think that one's due when? I already forgot the due date for that one. Okay, tomorrow. Tomorrow was limits 1, I think, and then or it might have been 2, limits 2. Yeah. UH quiz 5 trig limits. You know that one now, all of it. And then the handout that we passed out yesterday, ask me questions. The only one that we haven't done is the squeeze theorem, which we might talk about in a little bit today. All right, guys, that's it. Take care of business. Let's make sure we're working on calculus.